Hello, and welcome to Advanced Mathematics 1, Unit 6, Part 1, Solving Systems with Substitution. By the end of today's lesson, you will be able to do the following. Solve systems of linear equations with substitution, and identify systems of linear equations with special solutions. Basically, when we're solving a system of equations, we are looking for where the two lines cross. We could graph both lines, but they don't always cross at nice points, so it's not the most consistent way of solving systems of equations. Okay, our main concept for today is basically the process of solving a system by substitution. So you start by solving one of the two equations for one of the variables. Sometimes you'll get lucky and it's already done that way, which is nice. It saves you a step, but that's where you have to start. Then you take that expression that you just solved for. So like if it's a y equals x plus 6, you take x plus 6 and you shove it in to the other equation for y. So it's very much like at the very, very beginning of the course when we were putting in numbers for letters, we're just putting in a letter expression for a different letter. Then you use the value that you find in the first equation that you solve. So you get like x equals 6 or y equals 7 to find the other variable. So you go back to the first equation that you solved, so for y or for x, and you plug that value in. And last but not least, you write the answer as an ordered pair where applicable. Basically, that's if the variables are x and y. If there's something else, then you just write what each variable is equal to. But you need to write it as an ordered pair because we're looking for where those lines cross. All right, in this first example, we have it all set up real nice where the first equation is already solved for y, so that first step we don't have to do. The second step is we're going to take that value of y and we're going to put it in to the other equation in place of the y. What I do is I copy the equation all but the y. So I write 6x minus 5. I put a parentheses where the y is, so I have a space to work, and then copy the rest. And then I take that value from up top, negative 2x minus 9, and I put it in here in the parentheses. And then you can solve this for x because it's a normal equation. So I have 6x minus 5 times minus 2 is positive 10. Negative 5 times negative 9 is positive 45. And just to save myself some space, I'm going to kind of do two steps at once. I'm going to go ahead and subtract this 45 from both sides at the same time as combining the like terms of the x's. So 6 and 10 is 16. And 45 and 19, both negative, add to negative 64. And then we'll divide everything by 16. So 64 divided by 16. The answer is going to be negative, so x is negative 4. Now we're going to take that value back up to this original equation that was solved for y. So we have y equals negative 2 times x, which is 4, minus 9. And then you can just figure that out. So negative 2 times 4 minus 9 is negative 17. So now my final step is to write this as an ordered pair, which would be the x coordinate first and the y coordinate second. So negative 4, negative 17 is my answer to this first problem. In the second problem, neither one of them is solved for either variable. What you want to do when that is the case is you want to look for one that has a 1 in front, if at all possible, of the variable. So the x's both have a 5. This one has a 3. This one has a -1, but I'll take that. So I'm going to solve that for y. So I'm going to kick the 5x to the other side. So it's going to become negative on the other side. If you need to write the -5x, go ahead. I'm just not going to do that for brevity's sake. Then I got to divide by -1. So I get y equals 5x minus 5. So that's the value of y that I'm going to plug in to this top equation because I used the bottom equation to solve. So I have 5x plus 3 parentheses equals 11. I put that 5x minus 5 in the parentheses, and then I solve it. So I have 5x plus 15x. 3 times -5 is also 15, but negative, and 11 over here. Again, I'm going to move the 15 and combine like terms at the same time. So 15 and 5 is 20. And 45 plus 11 is 56. So that doesn't go in evenly, but that's okay. So I'll divide that by 20, and that's 2.8. It does not have to be an even number. This is the case that basically reason why you can't always solve by graphing. So you're not going to be able to tell that something is 2.8 on a graph. So I'm going to plug that value into the equation that I solved for y. So I have y equals 5 times 2.8 minus 5. So I'll figure that out. 5 times 2.8 minus 5 is 9. And then I write my ordered pair at the end, which will be 2.8, comma 9, xy. Oop, there we go. Sorry about crossing through my 11 there. Sometimes mouses are a pain in the butt. All right, in these last two examples, we're going to deal with two special cases that can come up. Basically, there's a case where the lines are parallel, so they never cross. And there's actually a case where both lines are technically the same line, written differently. So that's basically what we're looking for with both of these, but the process stays exactly the same. Again, this one's already solved for y, so I can plug that in. So I have 2x into that second equation plus 2 parentheses equals 4, and I have -x plus 3. This is a 2 out here, by the way. I'll try and fix that. There we go, kind of can see. All right. So let's go ahead and multiply this through. 2x minus 2x plus 6 equals 4. In this case, I'll just say 2x minus 2x is no x, and I get something that says 6 equals 4, which is an untrue statement. So that means this has no solution. It means the original lines were parallel, and they never, ever cross. All right, the second one, again, I need to solve one of them for one of the variables first. This one has a y by itself, so that's the one I want to solve. So I'm going to kick the 2x to the other side. When doing so, It changes signs, so it's positive where it is now, so it's negative on the other side. That just saves me that step of writing minus 2x minus 2x. But like I said, if you need to do it, do it. It's all what makes you things work for you. So I've been doing this a long time. Okay, so now we're going to take that value and we're going to plug it into the second equation. So we have negative 4x minus 2 times y, which we'll put that parentheses in there, equals negative 8. So we have negative 2x plus 4 in here. So I have negative 4x plus 4x minus 8 equals negative 8. So again, the x terms drop out, and I end up with negative 8 equals negative 8. So that is a true statement. So that means these are both the same line. So what you do when that is the case, you pick one of the two equations. I'm going to use this one because it's the simplest of the two. And this is how you write the solution. It's kind of funky. So you write the set of all x comma y that are elements of the real numbers such that that's the case. So 2x plus y equals 4. Because that entire line is the solution, since they basically are the same line. They cross each other the entire time. So it's just a funky way of writing it, but it's the way that you need to write it. And I know it's kind of a pain, but you'll get used to it. It's no big deal. That's it for today, and I'll see you next time. Goodbye.